Welcome back to the CCNA series. In this chapter, we're diving into one of the most important foundation of your networking journey, getting hands-on with Cisco IOS devices. Today, we're building your own lab environment, exploring Cisco IOS and learning how to configure real routers and switches. Let's get straight into chapter 2. Hands-on practice is essential for mastering Cisco technologies. This chapter shows you how to build your own environment, virtual or physical, so you can practice anytime, even without access to classroom equipment. You'll learn how to build a Cisco lab environment, basics of Cisco IOS devices, how to access a Cisco IOS device, initial IOS configuration, troubleshooting fundamentals. You can train using virtual labs, physical hardware, or a mix of both. Use simulation emulation tools to practice without buying hardware. You have a few virtual options. You have the Cisco Packet Tracer. You have GNS3, virtualization software, VirtualBox or VMware workstation. Supported Cisco images are Cisco IOS V, Cisco IOS VL2, Cisco CSR1000V. Why virtual labs? They're free, portable, fast to reset, and almost identical to real hardware. If you want real gear for exam realism or job skills, here is a minimal recommended setup. Routers, you'll want your Cisco 2911, 1 to 2 recommended. Switches, you'll want Cisco 2960 switches, layer 2. And one advanced switch. I recommend the Cisco 3560 or the 3650, layer 3 switching. Cables, you'll want your console cable, you'll want the RS232 to USB converter for modern PCs, and network patch cables, straight through and crossover. You'll learn real-world tasks, such as cabling, boot processes, hardware errors, and interface issues. Before configuring devices, understand iOS basics. iOS, the operating system that controls routers and switches. Work is done mostly in the CLI. Commands follow a hierarchical mode structure. You can connect to a Cisco device through using PuTTY or similar terminal software. Requires a console cable and a USB adapter, used for first-time setup or recovery. Remote access, you'll want SSH, which I strongly recommend, or you could use Telnet, not so secure. Once inside the device, you can enter privilege mode by using enable. You can enter global configuration mode by configure terminal, and configure interfaces, hostnames, passwords, routing, VLANs, etc. You'll learn configuration syntax, verification commands, and iOS help features. Key troubleshooting tools include show commands, you got ping and traceroute, check an interface status, up or down, diagnosing layer 1, 2, 3 issues, resetting configs or reloading devices safely. Troubleshooting is a major CCNA skill. Practice it often. Hardware, you'll want a computer, console cable plus USB converter if working with real hardware. Software, you'll want PuTTY, Packet Tracer, GNS3 plus GNS3 VM. You'll want VirtualBox or VMware. You'll want Cisco IOS V, IOS VL2 images. Optional physical hardware. You'll want Cisco 2911 routers, Cisco 2960 switches, Cisco 3560, 3650 switch, and you'll want your network patch cables. Hands-on practice is essential for CCNA success. The best way to learn Cisco technologies is by building labs and configuring devices as you study. You can do this using virtual tools, physical hardware, or both. Cisco Packet Tracer. This is a lightweight network simulator created by Cisco Networking Academy. It allows you to design, configure, and troubleshoot Cisco networks without needing physical routers or switches. It is ideal for CCNA learners because it supports most features taught at entry level. Why use this packet tracer? It's free to access through Cisco Networking Academy. perfect for learning CCNA level concepts, allows complete lab building and troubleshooting, lets you copy configurations directly to real Cisco devices, no hardware cost, no iOS licensing issues. While physical devices offer the most realism, Packet Tracer provides nearly identical configuration commands and is far more accessible for beginners. Packet Tracer requires enrollment in Cisco's Intro to Packet Tracer course. This course also includes tutorials that help you learn the interface and simulation features. Go to netacad.com. Now log in or sign up with your credentials. After you successfully logged in, as you can see, I've already got the course there. But you can go up to the top and search. Now type in Packet Tracer and click on courses and click getting started with Cisco Packet Tracer. Now if you scroll down, go to module 1, you'll see install Cisco Packet Tracer. Now if we start the course, and you could scroll down a little bit, you will have download Cisco Packet Tracer. You will need this. Download the version for your operating system and install it. Now open Packet Tracer. At the bottom left, you'll see two icon rows. Top row, device categories. Bottom row, subcategories. Click a category, choose a sub, available devices appear. Drag a Cisco 2911 router onto the workspace. Drag a PC from the End Devices category. Select the Connections category. This is the lightning bolt icon. Choose the console cable. Click the PC, select RS232, and connect the other end to the router's console port. On the PC, open Desktop and click Terminal. Click OK to open the CLI. The router will boot, decompress iOS, and display the Cisco IOS prompt. You now have a working virtual console session to practice real CCNA commands. Cisco Packet Tracer is one of the fastest, cheapest, and most accessible ways to gain hands-on experience. It mirrors real iOS commands and allows you to practice nearly all CCNA level skills. Next, we'll explore more advanced emulation tools such as GNS3, which offer deeper realism and support for real iOS images. Now we're going to set up GNS3. Go to GNS3.com and click sign up and create an account. Log in and select download. You want to download both GNS3 standalone client and GNS3 VM. When downloading the VM, choose the version for your hypervisor. Here I'll be using VMware. Installing a hypervisor, you can use VirtualBox. It's recommended because it's free. You can just go to virtualbox.org, select downloads, and install using the default settings. Install the GNS3 standalone client with default options. Now we're going to right click the GNS3 VM file and open it with VMware. Import it to the VM. I'm using 6 GB here of RAM, 1 processor, and cores per processor 2, and enable CPU virtualization extensions. The VirtualBox settings, you'll import the VM, adjust the CPU and RAM to similar values. Now open the GNS3 client, go to Edit, Preferences, select GNS3 VM, enable the VM and choose your hypervisor. I'll be choosing VMware. Click Apply and OK. You should now see GNS3 VM listed in the server summary pane and marked as available. Now we'll be adding a Cisco IOS image to GNS3. Ensure GNS3 client and GNS3 VM are both running. Click the router icon, select New Template, choose Install an appliance from GNS3 server, Search for Cisco IOS V and click Install. Choose Install on GNS3 VM. Accept the defaults and click Next. Import your Cisco IOS V image. Download or import the required startup config file. Once both files are uploaded, the status becomes ready to install. Click Next and Finish. Follow the same process for IOS V L2, the Cisco Layer 2 switch. Now we're going to go to File, New Blank Project. Name the project. I'll just name mine CyberEd. Click OK. Now click the router icon and drag your IOS V router onto the canvas. Click play to start the device. The router icon will turn green, indicating it is powered on. To access the CLI, double click the device icon and PuTTY will pop up. This was included in the installation. You now have full iOS access. For adding more devices, drag additional routers, switches, PCs or appliances. Click the cable icon to connect the interfaces. If you want to shut down, just click the stop button, or closing GNS3 also powers off the GNS3 VM automatically. While virtual environments are extremely useful, nothing replaces the experience of working with real Cisco hardware. Physical labs give you hands-on exposure to cabling, boot sequences, interface LEDs, hardware failures, and real traffic flow skills that are invaluable for network engineers. For an effective CCNA level physical lab, the following devices are ideal: your Cisco 2911 routers, Cisco 2960 switches, one layer 3 switch, your Cisco 3560 or 3650, one Cisco console cable, one RS-232 to USB adapter, assorted patch cables straight through and crossover. Optional extras, you can have your second laptop or PC for end-to-end testing, a small rack or shelf to organize your equipment, and a power strip with surge protection. Use as many routers and switches as your budget allows. A common CCNA starter lab setup looks like 2 routers, 2 switches, 1 PC or laptop per side. This allows you to practice routing, VLANs, trunking, inter-VLAN routing, Ether channel, STP and more. Ensure each device runs the latest available iOS version for that model. Newer iOS versions include updated features you may need for CCNA practice. By completing this section, you now understand the advantages of real Cisco hardware, which devices are ideal for a CCNA physical lab, and the minimal equipment needed to build a functional environment. You now have everything required to build either a virtual or physical Cisco lab. Next, we'll start exploring the Cisco IOS operating system, the CLI structure, and how to configure devices efficiently. Cisco routers and switches do not use traditional hard drives or SSDs. Instead, they store iOS and configuration files in flash and NVRAM, which retain data even when powered off. The Cisco IOS boot sequence follows these steps. Your power on self-test runs automatically when the device powers on and checks hardware components for issues. Bootstrap loads from ROM, a small program in ROM that starts the boot sequence, locates the iOS software. Your iOS loaded from flash. Bootstrap loads the Cisco IOS image stored in flash into RAM. RAM is where iOS actually runs. If iOS not found in flash, the device attempts to load iOS from a TFTP server on the network. Common in enterprise environments where iOS images are centrally stored. If TFTP fails, device loads a minimal iOS ROM monitor mode. This mode allows basic recovery and reloading of iOS into flash. Your load up startup configuration. If a startup config file exists in NVRAM, it is copied into RAM as running config. If no startup config exists, default settings load instead. Keynotes, running config lives in RAM, lost on power off. Startup config lives in NVRAM, must be saved manually. Cisco routers and switches do not have built-in screens. Instead, you access the CLI using a console connection. A standard Cisco console cable has DB9 RS232 connector, plugs into older PCs, and a RJ45 connector, plugs into the Cisco device's console port. Because modern laptops really have RS232 ports, you will need a USB to RS232 adapter. The console port lets you perform initial configuration, recover devices, and troubleshoot when the network is down. Remote access methods, SSH and Telnet, will be covered later. To access the CLI through the console port, you need a terminal emulator. Common options, PuTTY, SecureCRT, and TeraTerm. So connect the console to the device, connect the RJ45 end to the device's console port, identify the COM port. On Windows, open Control Panel, go to Device Manager, expand ports, note the assigned COM port. Open PuTTY and configure session. Use the following settings. Now open the terminal, click open. You should see the Cisco IOS startup messages and eventually a CLI prompt. This is your entry point to configuring the device. By this point, you should understand what Cisco IOS is and why it uses a CLI, how a Cisco device boots and where IOS and configs are stored, how to connect to a device using the console port, and how to use PuTTY to access the router or switch. Next, we'll explore navigating iOS, understanding modes, and using Cisco commands effectively. The Cisco Internetwork Operating System is the software that controls Cisco routers and switches. It provides hardware control, networking features, and a CLI for configuration and troubleshooting. iOS uses different command modes to separate user access and configuration tasks. User exec mode, default mode after console login, limited commands, basic tests like ping, traceroute. Privilege exec mode. This gives you full access to operational and troubleshooting commands and can access global configuration from here. And you can enter with enable and exit back to user exec, disable. Prompt ends with a hashtag. Global configuration mode, used to configure the device, affects overall operation immediately. To enter from privilege exec, you'll use configure terminal, and exit to privileged exec, you'll use exit. From global config, you can enter more specific modes, like interface mode, line configuration, and router configuration. Here's a few iOS navigation tips. Control and Z, jump back to privileged exec from config modes. Your tab auto-completes commands, supports abbreviations. For instance, you got show, IP, interface brief. You can use SH, IP, INT, and BRI. Command, here you got command history. Use the up-down arrows to scroll through recent commands in the current mode. And context-sensitive help. That would be EN ? Or show ? List all valid options after show. When long output is shown, more appears. Press space for next page, enter for next line. Here's a lab topology overview for the small network lab. And you can build this in physical hardware, packet tracer, or GNS3. Now we have a few cable types. So you got your straight through, PC to switch, switch to router, and switch to server. And crossover, you'll have PC to PC, switch to switch, router to router, and router to PC/server. When a router boots for the first time, you may see system configuration dialog. Would you like to enter the initial configuration dialog? Yes or no? Type no and enter until you see router. From there, you could type enable to go from user exec to privilege exec and disable back to user exec. Use question mark, abbreviations, and history as described earlier to explore commands. Now changing the hostname. Guidelines for hostnames: no spaces, max 64 characters, and start with a letter, end with a letter or number. The prompt updates immediately after hostname. Configuring IP addresses on router interfaces. First check interfaces. Show IP interface brief. This shows interface type and number, IP address, status, and protocol. Typical speeds: Ethernet 10 megabits per second, fast Ethernet 100 megabits per second, and gigabit Ethernet 1000 megabits per second. Now we'll configure R1 interface to LAN 1. Now we'll configure R1 interface to LAN 2, and then we'll verify it. Configuring SVIs on layer 2 switches. Layer 2 switches don't get IPs on physical ports, so we create a switch virtual interface, SVI, for management. Now we're going to be securing administrative access. Secure the console port with line console, password, login, and exit. Now, console access prompts for a password. In production, always use stronger passwords. Now secure privilege exec. Enable secret, and this is recommended. So we have two methods here. You have the unsecure method, which you should avoid. And this is enable password and whatever the password is. And the secure method is enable secret and the password. If both exist, enable secret takes precedence. Remove the weaker one with no enabled password. Setting a login banner. Use a message of the day banner for legal warnings. So here we'll type banner MOTD %sign only, and we'll just type authorized access is permitted. The %sign here is just a delimiter. You can use hashtag, @ or the $, etc. Everything between the delimiters is shown before login. Setting up remote access, telnet and SSH. So with a PC1, we'll set the IP as 192.168.1.20, mask 255.255.255.0, and default gateway 192.168.1.1. Now PC2 will use 192.168.2.20, same mask, default gateway 192.168.2.1. Try ping it, should all show okay. Configure telnet, it's not secure so it's for practice only. You'll configure terminal, line VTY 015, password, login and exit. Then from PC1's telnet client, connect to 199.168.1.1 using telnet. You'll see the message of the day banner and password prompt. Now we'll configure SSH, which I recommend. Set the domain name, generate the RSA keys, create a local user, configure VTY lines for SSH only and local login. Now, only SSH is allowed, and users must authenticate with the local username and password. Now, default gateway for switches for remote access across networks. Go IP default gateway 192.168.1.1. That's for WS1. WS2, the same except 192.168.2.1. Using local user accounts on the console. Use the same local account for console login. Line console 0, no password, login local, exit. Disabling DNS lookup and encrypting plaintext passwords. Disable unwanted DNS lookups. iOS tries to resolve unknown commands as hostnames, which can hang the CLI. Disable it. No IP, domain, -lookup. You can abort a lookup with Control and Shift and up. Encrypt all plaintext passwords. Use the service password encryption. This encrypts all current and future plaintext passwords in the configuration. Now to check version, use the show version. This shows iOS version, system image file, uptime, hardware model, etc. Changes are stored in running config. To save them to startup config, copy running config, startup config, destination file name, and press enter, and it will build the configuration here. To confirm persistence, you can run reload. After reboot, the device loads startup config. Now, performing troubleshooting procedures. After configuring a device, it's best practice to verify your work using iOS show and test commands. Throughout your CCNA journey, you'll add more tools and techniques, but two core client-side tools you'll use constantly are ping and traceroute. Ping checks whether a source can reach a destination IP address, and you'll simply type ping and the IP address. On a Cisco IOS, the results are shown as characters instead of full sentences. The key symbols are the exclamation mark for success, that means a reply is received, a full stop, that means a request is timed out, so you will have no reply, and U, destination is unreachable. If ping fails, you can start checking interface status, IP address and masks, default gateway, routing configurations, and cabling and physical links. Traceroute shows the path packets take through the network and where they might be failing. You'll simply type traceroute and the IP address. This helps you see which hop along the path is dropping or delaying traffic. In this chapter, you built Cisco lab environments, virtual and physical. Virtual, we use Packet Tracer and GNS3. We learned the basics of Cisco iOS devices, practiced iOS navigation and modes, configured a small rooted network, secured administrative access, used show, ping, and traceroute for verification and troubleshooting. The key mindset: don't be afraid to break things in the lab. Make changes, test, break, fix, repeat. That's how network engineers build real skill, through configuration, troubleshooting, and problem solving. In the next chapter, IP addressing and subnetting, we'll dive into IP addressing fundamentals, subnetting, variable length subnet masks, all of which you'll apply directly in your lab environments. I'm CyberEd, and I'll see you in the next chapter.